a burial site in Gilan province, northern Iran. The hills above the Caspian coast, where the air hangs heavy with moisture and the soil keeps its secrets better than most. Archaeologists from the University of Social Welfare and Rehabilitation Sciences in Tehran are lifting bone fragments from catacomb-style graves that date to the Parthian Empire, sometime between the 3rd century BCE and the 3rd century CE. The skeletons are delicate. The petrous bones behind the ears, the densest bone in the human body, are what the geneticists want, because inside those fragments sits ancient DNA that has survived nearly 2,000 years underground. And when that DNA is finally sequenced, it will say something that contradicts what nearly every history textbook printed in the last century has taught about where the Persians came from. That is the scene. It is not dramatic. It is careful, quiet, technical. But the results it produced are anything but quiet. Here is what most of us were taught. The Persians, like the Medes, like the Indo-Aryans who moved into South Asia, were steppe people, nomadic herders from the grasslands north of the Caspian and Black Seas, speakers of an early Indo-European language, who migrated southward into the Iranian Plateau sometime between 2000 BCE and 1000 BCE. The first Assyrian mention of the Persians dates to 843 BCE, when they appeared on the northeastern frontier of the Assyrian Empire as raiders. From there, the narrative goes, they moved deeper into the plateau, settled a region called Persis, modern Fars province, conquered the kingdom of Elam, absorbed the Median Empire around 550 BCE, and under Cyrus the Great built the largest empire the ancient world had yet seen. They brought horses, chariots, and a language that would become Old Persian, the tongue of Darius and Xerxes, carved into the cliff face at Behistun. They brought Zoroastrianism. They brought the word Arya, which Darius himself inscribed at Naqsh-e-Rostam to describe his own lineage. A Persian, son of a Persian, an Arya of Arya origin. The implication was clear. The Persians arrived. They were outsiders who became insiders, conquerors who became civilizers. And this story, for decades, felt settled. The linguistic evidence was strong. Old Persian belongs to the Indo-Iranian branch of the Indo-European family, and that family tree traces back to the Pontic Caspian steppe with a confidence that few linguists seriously dispute. Old Avestan, the sacred language of Zoroastrianism, is so close to Vedic Sanskrit that scholars can transpose entire sentences sound by sound from one to the other. That proximity only makes sense if both languages descended from a common ancestor spoken by a single community, likely somewhere in Central Asia, before they split and moved in different directions. The archaeological evidence seemed to support it too. The Sintashta culture, dated to around 2100 BCE, produced the oldest known chariots. Its successor, the Andronovo culture, spread across the Central Asian steppe, and material connections between Andronovo sites and the Bactria-Margiana complex further south suggested a corridor of southward movement into Iran and India. The pieces fit. The Persians came from the north. But language and DNA do not always travel in the same direction, and that is the fault line this story sits on. To understand why the textbook model held so long, you need to understand what tools were available. For most of the 20th century, the origin question was answered by linguistics and archaeology alone. You looked at where the language family branched. You looked at where chariot burials appeared. You looked at shared pottery styles and horse-bit designs. And those threads all converged on the steppe. The logic was sound as far as it went. If the language came from the steppe, the people must have come from the steppe. The assumption was that languages travel inside populations, entire populations. That when Old Persian arrived on the Iranian Plateau, it arrived inside a wave of migrants large enough to reshape the gene pool. This was not a fringe position. It was the default framework in historical linguistics for the better part of a century, and it survived because there was no way to test it directly. Ancient DNA did not exist as a viable tool until the 2010s. And even then, the Iranian Plateau was one of the last regions in West Asia to be systematically sampled. Hot climates degrade DNA. Petrous bone extraction techniques were not refined until around 2015, and access to Iranian archaeological sites for Western genomic labs was complicated by politics and logistics. So the steppe migration model sat in place, unchallenged by the one form of evidence that could actually confirm or deny it. The first crack appeared not in Iran, but in a cave in the Zagros Mountains on the Iranian-Iraqi border. In 2016, two teams published landmark papers within months of each other. Brushaki and colleagues, writing in Science, sequenced 4 early Neolithic genomes from the Eastern Fertile Crescent, including a well-preserved male from Wesme Cave, dated to approximately 74 to 55 BCE. What they found was startling. These Zagros farmers were genetically distinct from the Anatolian Neolithic populations who later spread into Europe. The two groups had separated somewhere between 46 and 77,000 years earlier. That is not a regional difference. That is a deep continental split, running through the heart of what everyone assumed was a single Fertile Crescent population. Meanwhile, Gallego Llorente and colleagues at the University of Cambridge published the first genome from Geneticists, Darech, a site in Kermanshah province, western Iran. The individual was a woman who lived around 10,000 years ago, at a site famous for providing the earliest evidence of managed goat herding, dating to approximately 9,900 years before present. Geneticists sits at an altitude of 1,400 meters in the Gamasab Valley of the High Zagros Zone, a classic mound site roughly 40 meters in diameter, with 7 to 8 meters of Neolithic cultural deposits, 5 occupation levels, evidence of underfloor burials. This was not a temporary camp. This was a community that stayed. Her genome placed her closest to Caucasus hunter-gatherers, not to Anatolian farmers, not to Europeans. On a principal component analysis plot, she fell near modern Pakistanis, Afghans, and, critically, Iranian Zoroastrians, the one group most likely to have preserved pre-Islamic genetic heritage on the plateau. Her maternal lineage and those of other Geneticists individuals included haplogroups R2, X, J, U, and HV, lineages that are still present in modern West and South Asian populations today. 10,000 years later, the thread is still there. 2 separate teams, 2 separate sites. The same conclusion. The people living on the Iranian Plateau 10,000 years ago were not part of the same gene pool that seeded European farming. They were a distinct, deeply rooted population, one that had been in place since the end of the last ice age, if not longer. Now, here is where it gets genuinely complicated. The steppe migration model was never wrong about the language. Old Persian is Indo-European. The linguistic evidence is overwhelming. The question was always about the people who carried it. And as more ancient DNA accumulated from the plateau, the answer that emerged was, in retrospect, obvious. But at the time, it blindsided the field. The people of the Achaemenid Empire, the Parthian Empire, the Sassanid Empire, the people we call Persians, were overwhelmingly genetically local. In 2025, Amjadi and colleagues published the largest ancient DNA study to date from the Iranian Plateau. 50 samples, 9 archaeological sites, 13 nuclear genomes spanning from 4,700 BC to 1,300 CE. The Achaemenid, Parthian, and Sassanid period individuals sampled from sites like Marsin Chal, Liarsang-Bon, and Vestamin in northern Iran showed genetic profiles dominated by the same 2 ancestry components that had been present on the plateau since the Neolithic. Caucasus hunter-gatherer, related ancestry, and early Neolithic Iranian farmer ancestry, the same deep lineage represented by that woman from Ganjdara. These 2 components persisted at levels of 45 to 51% through the Iron Age and into the historical period. Bronze Age steppe ancestry, The signature you would expect from a mass migration of Indo-Iranian herders was, in the study's own words, relatively minor. If you have been following this channel's coverage of ancient DNA and what it reveals about the peoples of Western Asia, you already know that the disconnect between language and genetics is not unique to Iran. We have seen it with the Turkmens, who speak a Turkic language but genetically resemble their Indo-Iranian neighbors. We have seen it with the Azerbaijanis, whose Turkic language overlays a genome that clusters with Georgians and Armenians. But the Persian case is arguably the most consequential, because it sits at the foundation of how we narrate the origin of one of history's largest empires. If the collision between old narratives and new genetic evidence is the kind of content that keeps you watching, consider subscribing. We are building something here, and the next few months will go deep into the genetics of empire. Let me be specific about what the DNA shows, what it rules out, and what it implies. What it shows. The historical period populations of the northern Iranian Plateau, living during the Achaemenid through Sassanid eras, carry a genetic signature that connects them directly to local Bronze Age populations and, further back, to Neolithic farmers of the Zagros. The study modeled their proximal ancestries and found strong connections to Bronze Age sites like Gonur Tepe and Sapali Tepe. Their Y chromosomal haplogroups belong to haplogroup J, every single one. Not a single case of R1a, the Y DNA marker most strongly associated with Bronze Age steppe pastoralists, and the spread of Indo-Iranian languages into Central and South Asia. 0. What it rules out: a large-scale population replacement. If the Persians had arrived as a migrating steppe population in the numbers the textbook model implies, their genetic footprint should be unmistakable. R1a should appear at significant frequencies in Achaemenid-era burials. Steppe-related autosomal ancestry should be a major component, not a minor one. The data do not support that. The steppe signal is present, but it is small, consistent with contact and gene flow over centuries, not a founding migration event. What it implies: that the spread of Indo-European Persian across the plateau was likely an elite dominance event. A relatively small group of Indo-Iranian speakers, possibly a warrior aristocracy or a trading elite, arrived on the plateau and established linguistic and cultural hegemony without replacing the existing population. The local people, descended from those deep Zagros lineages, adopted the new language, the new religion, possibly new political structures, but they remained, genetically, who they had always been. The ground did not change hands. The grammar did. This is where the debate gets heated, because the elite dominance model is not universally accepted, and the stakes are high. The spread of Indo-European languages is one of the most politically charged questions in historical linguistics, and the answer you give shapes how entire civilizations understand their own origins. Some researchers argue that the steppe signal, while small, could reflect a highly sex-biased migration, a small number of high-status males whose cultural influence far outweighed their demographic footprint. In Europe, we know that steppe migrations were heavily male-biased, with incoming Y chromosomes replacing local lineages far more dramatically than autosomal DNA. Something similar could have happened in Iran. A warrior elite that imposed its language and religion through prestige and power, marrying local women, generation after generation, until the Y DNA signature itself was eventually diluted or outcompeted. The absence of R1a in the 2025 study is notable, but the sample size, though large for ancient DNA, is still limited to specific sites in northern Iran. 13 nuclear genomes is a lot by the standards of ancient DNA, but it is not a census. Southern and eastern Iran remain poorly sampled. Others point out that the BMAC, the Bactria Margiana archaeological complex in what is now Turkmenistan and Afghanistan, served as a staging ground for Indo-Iranian expansion. The BMAC population was itself formed primarily from Iranian Neolithic ancestry, roughly 60 to 65%, with additional Anatolian farmer and West Siberian hunter-gatherer components. Populations moving through the BMAC may have already been heavily admixed with local Iranian Plateau-related ancestry before they ever reached Persis. In other words, the steppe signal may have been diluted before arrival, making it difficult to detect even if the migration was demographically significant. This is a genuine methodological problem. If the migrants already looked partially local, the DNA alone cannot easily distinguish them from the people who were already there. And there is a third position, less commonly voiced but worth hearing. Some scholars question whether the steppe origin of Indo-Iranian languages is as settled as the consensus assumes. The 2019 study by Shindi and colleagues, published in Cell, showed that the Iranian-related ancestry in the Indus Valley civilization derived from a lineage that split from actual Iranian plateau farmers before those farmers started farming. That finding complicated the simple west-to-east migration story. If ancestry flowed in multiple directions across this region long before the Bronze Age steppe expansions, the linguistic family tree might not map as cleanly onto population movements as we have assumed. There is also a deeper wrinkle. A 2024 study by Valini and colleagues, published in Nature Communications, identified the Persian Plateau as the geographic hub where Homo sapiens lived for roughly 20,000 years after the initial migration out of Africa, between 70 and 45,000 years ago, before dispersing to populate Europe, East Asia, and Oceania. If that finding holds, the genetic roots of the Iranian Plateau go back not 10,000 years, but 70,000. The plateau is not just the homeland of Persian civilization. It may be the staging ground for the settlement of the entire non-African world. That makes the genetic continuity finding even more striking. Empires rose and fell on this land. The Elamites, the Medes, the Achaemenids, the Seleucids, the Parthians, the Sassanids, the Arab conquest, the Mongol invasion. And through all of it, the deep Zagros ancestry held, 50% or more, unbroken, for millennia. There are things we still cannot explain. The study's authors acknowledge that only 2 medieval genomes are currently available from the Iranian Plateau. The transition from the Sassanid period into the Islamic era, one of the most transformative cultural shifts in the region's history, remains almost entirely uncharted genetically. Did the Arab conquest bring measurable gene flow into the plateau? Did the Mongol invasions, which devastated cities like Nishapur and Merv, leave a detectable Eastern Eurasian signature? We do not know. We also do not know the full geographic scope of the steppe signal's absence. Northern Iran, south of the Caspian Sea, is just one corner of the plateau. The heartland of the Achaemenid Empire was in Fars province in the southwest. Persepolis is there. Pasargadae is there. The tomb of Cyrus the Great is there, and we have almost no ancient DNA from those sites. The picture could change. That is worth saying plainly. There is also the question of the Medes, the people who controlled the northern and western parts of the plateau before the Achaemenids absorbed them. The Medes were, by all accounts, an Iranian-speaking people. Were they too genetically local? Or did their northwestern position, closer to the Caucasus corridor, make them a more plausible vector for steppe ancestry? Without ancient DNA from Ecbatana, their capital in modern Hamadan, we are guessing. What we can say is that the framing of the Persians as a migrant steppe, people who arrived and built an empire, now looks, at minimum, incomplete. The people who built that empire were already there. They had been there since they first herded goats in the high valleys of the Zagros, since they buried their dead under the floors of mud brick rooms at Ganj Dareh, since, perhaps, they stood on this same plateau and watched the glaciers retreat at the end of the last ice age. There is a tendency, when a population is discovered by DNA to have deep local roots, to treat it as a vindication. National pride seizes the finding, Social media turns it into a meme. But what the genetics actually show is something more interesting than simple ownership. They show that identity, the kind Darius carved into stone, the word Arya, the language, the religion, the political system, these things can arrive from outside and be adopted completely, transformed into something native, without the population itself being replaced. Language traveled, culture traveled, the people stayed. Right now, in Tehran, a new generation of Iranian geneticists trained at institutions like the University of Social Welfare and Rehabilitation. Sciences is pushing to sequence more ancient genomes from across the plateau. The 2025 study is explicit about the gaps that remain. Fars Province, Khuzestan, the Eastern Deserts, Sistan-Baluchistan. Every site sampled will either deepen the continuity story or complicate it. But either way, what has already been shown will not be erased. For 3,000 years, through the rise and fall of 4 empires, through conquest and conversion and revolution, the DNA held. And that connects to something happening right now. Today, over 80 million people live in Iran, speaking Persian, a language whose Indo-European structure can be traced back to the steppe. But the bodies carrying that language, the genomes beneath the grammar, those trace back to the Zagros, to the plateau itself, to a time before agriculture, before empires, before the very concept of Persia existed. The 2025 study's authors describe it as genetic stability in the face of historical migrations and cultural shifts. That phrase, understated as it is in a scientific paper, carries an enormous weight when you step back and consider the scale of what it describes. The ancestors of the Persians were not arriving. They were already home. If ancient DNA from Persepolis or Pasargadae, the actual ceremonial heart of the Achaemenid Empire, confirms the same pattern of Zagros-rooted continuity that northern Iran shows, what does that do to the story of how Indo-European languages spread? And should we rethink how we use language families to reconstruct migration in other parts of the world?